Looks like it. Hey, everybody. Welcome to today's webinar. We're ready to get started on how 5G is changing the network visibility game. I'm Marshall England, Vice President of Mantis Networks, and I'll be the moderator for today's webinar. Very quickly, let's review some housekeeping items. Registrants can access a PDF of today's slides below the webinar window in the attachment section. Additionally, a link to the recording of this webinar will be sent to the email you registered with. For any questions you have, you can submit them using the question area of your webinar control panel. And we will address submitted questions during the Q&A portion of the webinar. And for questions we aren't able to get to, we will respond with an email to the email address you provided. And the webinar is listed for 45 minutes, but we'll likely cover the topic and questions in about 35 minutes. So next, I'd like to introduce today's speakers from MantisNet. Mike Fetcher is a technical account manager who works with telecommunications providers and U.S. government agencies on network visibility, infrastructure, and cybersecurity solutions. Elliot Starin is the founder and CTO of MantisNet. He has over 25 years of experience in researching and developing advanced networking, signal processing, and communication systems. I'm Marshall England, Vice President of Marketing. I've been in the cybersecurity and software industries helping organizations embrace digital transformation while managing cybersecurity and operational risk. And for those that aren't familiar with MantisNet, we are a network and endpoint intelligence software company founded in 2012. We develop software that simplifies the process to access and extract network intelligence in real time and at wire speeds, providing visibility to machine and wire data for detection, analysis, and response in a streaming metadata format. Our goal is to help companies reduce time to identify, detect, and respond to threats and performance issues with real-time data in motion. Our software enables full programmability of the data plane and can identify and extract network communications by protocol, organize it, and will create key value pairs that can be efficiently ingested into analytic and event-driven architectures. In doing so, we turn the network into a data science problem for real-time network detection and response functions. With that, I'll turn it over to Mike.
Thank you, Marshall, and thank you everybody on the line that had the time to join us today. Once again, Mike Fetcher here, a technical manager at MantisNet, and we'll just go ahead and take care of the logistics here and set up an overview of the agenda. So during the course of this presentation, we'll start off with a quick high-level look at the challenges within 5G through a visibility lens or establishing insight into the actual data from the edge to the core. And then we will move to discuss what really makes up a 5G sensor, and then move on finally to talk about what we here at MantisNet see as a right path forward to successfully achieving visibility within 5G environments, and that's through a Containerized Visibility Fabric. And we'll discuss the system design, what we call tasks and directives that allows us to do more than just capturing packets. And then we'll also talk about and spend a bit of time talking about how we're leveraging open standard messaging queues pretty significantly throughout our solution. And then we'll wrap things up with an architecture review. So starting with the challenges of 5G, and hopefully not to oversimplify things here, but really to break it down to kind of the simple, most core challenge. It's if you think about what 5G is, and whether it's a non-standalone architecture, a full standalone architecture, or anywhere along that curve, the truth about 5G is that it's really embracing virtualization, and be that a true cloud-native, containerized approach, or if it's leveraging VMs. Nonetheless, virtualized resources are being used, so you can no longer achieve full visibility into all the resources or the underlying resources of the environment by simply tapping the wire. Those days have now passed us. So in terms of breaking down the challenges, it's really about, how do you unlock what is hidden, right? The topology itself, the physical points from A to B, those virtual points within the physical points, looking at interfaces themselves, the network namespaces that are hidden from a wiretapping point of view as those namespaces are dynamically being spun up. Then the actual flow of information itself, the packets, the octets, which types of network protocols are being used. This is all internal to machines now and just part of the core problem at hand. So within the 5G visibility world, what really makes a sensor? And if we're looking at the approach that MantisNet sees as the best path forward, and that's utilizing a truly cloud-native visibility fabric, nothing changes in terms about, what really needs to be accomplished from any visibility fabric as step number one, and that's the ability to access, capture, and continuously monitor data. However, if you look at the recap of the challenges, that physical data, capturing the raw packet data off the wire itself is no longer going to be enough. You also have to get within at the virtual resource level to understand the communications that are occurring there. To take it a step further, a singular solution of just, placing sensors in an environment that can capture raw traffic or perhaps filter that traffic, it's not necessarily going to be enough to scale and to maintain scale with these systems that are promising extremely high throughput and connectivity. So we need to be able to leverage metadata really to move along with resources as they're expanding, and that includes looking at the control plane and the user plane to be able to correlate the users on the mobile devices and the network events that we're seeing throughout the environment, being able to look at the encrypted session metadata to see what is available in the open, and as well as to grab those asymmetric keys to pass along for decrypt down the road. Then, a huge topic that's evolved within 5G would obviously be looking at network slicing, resource utilization, and SLA metrics. And in terms of a visibility standpoint, the whole idea of network slicing is pretty game-changing for the providers of these environments, because it's rooted in the new idea of how these networks can be monetized. It's no longer about delivering the fastest transport to an entire wide swath of consumers. You can now look at network slicing to be able to segment specific groups of user equipment or specific users themselves and deliver very, specific performance to those users that are tied to SLAs. So having the ability to understand all of the virtual resources and components that from a network level are servicing that network slice and associated SLAs are going to be critical moving forward within 5G for full visibility. And then once again, back to the topic of understanding that virtual resource topology, being able to continuously map the topology as resources are being spun up and spun down, and to take it a step further to look at the flows associated with those changing topologies, not only understanding is A talking to B, but how often, and what is the overall volume from a high-level standpoint. And then finally looking at application and network performance metadata. The evolution from 4G to 5G, we're seeing less of a focus on, the terms of consumer experience, more of a focus on the terms of application experience or application performance, as 5G is servicing new markets where consumers meaning a human, may no longer be the only thing that needs to be serviced by these slices and SLAs. We're looking at specific applications and how do you marry that change and along with that change being able to track the metadata associated with application performance. And once again, looking at the entire Kubernetes stack, whether it is a true cloud native deployment that's leveraging Kubernetes containers throughout, or just, having that be a piece of a larger puzzle, but still being able to understand all of the internal components of Kubernetes from a visibility standpoint, be it that container to container interaction, pod to pod, pod to service, external to service, being able to capture the whole gamut. So now that we've taken a bit of time here laying out the land, we'll go ahead and discuss what I had mentioned MantisNet's path is forward, and that is to leverage and hope others leverage a Containerized Visibility Fabric, or CVF for short. So at the highest level, I'd like to break it down into two core pieces that make up the Containerized Visibility Fabric, and that would be the actual network agents or sensors that are put out into the environment, and then the server that is containing those agents. So let's go ahead and start with the agents on the left-hand side. So once again, these agents are network sensors that are lightweight containerized sensors, and you can deploy them anywhere back in the core out to the edge. And the idea with these agents, and we'll get into the details here momentarily, but it's to pivot away from having a singular function approach that other visibility fabrics may take, whether it's just capturing packets, filtering packets, what have you, but to take a composable design where you now have an agent that has a multitude of components or network visibility functions that can be accomplished, and they can be arranged and mixed and matched in a variety of ways based on the end user's need for visibility. So we'll discuss those different pieces, but the agents themselves can accomplish more than just one task. And finally, along with those tasks, the agents here, just to set the stage, they have the built-in quote-unquote tapping capability for the resources that they're being implemented on. And that just is really because we are leveraging an agent-based approach. They exist in that privileged state, have visibility into all of the interfaces themselves within the machine. So that just gives you that inherent tapping capability to all communication, physical or virtual. On the right-hand side with the server, the name may make you think otherwise, but this is a container, right, just along with the agents. So it is a lightweight container that's really responsible for managing the fleet of agents, if you will, that are out in the field from a configuration standpoint and a continuous management standpoint. We'll discuss here in just on the next slide, actually, exactly how the two interact, but server is responsible for the agents, and the server is issuing what we call tasks and directives to the agents themselves, and these are the different network functions, if you will, that the agents can actually deploy at any given point in time. So once again, that server is going to communicate to the agents and issue tasks and directives, and in front of you, I'll put a couple examples of what the agents can accomplish, the first being to generate topology metadata. So the server says to agent 1, I want you to start generating metadata regarding the topology. And then perhaps I also want you to start generating the flow metadata, the associated high-level performance of that topology. Some other examples of the tasks and directives would be looking at protocol metadata. So this would be 5G-specific network protocols, essentially pulling that information into the agent and having it egress as key value pairs that are broken down based on the protocol itself. So decoded, transcoded, parsed, whatever the vernacular would be, it's what the agent is doing from a protocol standpoint in generating metadata, and we will touch on that one in detail in a upcoming slide. And once again, raw packets, taking a singular approach of just grabbing raw packets is not going to scale well in the long term from a 5G visibility or within that environment. However, it is important to have that capability within the agents to grab raw traffic if you need to forensically or historically dig into a problem within the environment. And then the last function that we currently have available would be to generate that encrypted session metadata. So I don't want to beat a dead horse here. I think I've covered most of the topics at a very high level, but just to take an even higher step back, you can look at these tasks and directives or network functions really as plugins. So we have agents out there that have multiple plugins. So the 5 plugins you see in front of you are what are currently available. We have plans to expand on this functionality and to introduce new plugins. All of these plugins have open interfaces, so if others want to develop plugins, they can. But the idea is just to have that composable agent that can take multiple components, either essentially run 1 plugin, 2 plugins, 4 or 5, whatever the mix and match may be, to give that needed insight at any point in time by the end user. So now I'd like to just pivot and talk about, I had mentioned earlier in the presentation that we do leverage a message queue. So currently we're leveraging NATs, but you can think of any open messaging queue such as Kafka is a very familiar queue, but we're using the queue in 2 ways. So I'll walk you through how we're using it in both scenarios. The first would be how the server itself, that gray Mantis server on the bottom, is controlling and updating and telling these agents that are in green on the top what to do. So as I had mentioned, the server is responsible for sending up the directives into the agents. So the directive is essentially the instruction to a particular agent saying this is now your job and do that job until I tell you differently. And a directive can be broken up into essentially 1 or more tasks, the tasks being these color-coded circles on the bottom, be it capture that raw traffic, generate protocol metadata, etc. So how we're leveraging the messaging queue in our kind of orchestration of our environment is the server acts as the publisher into the queue, and the agents are going to be subscribing to a single topic on that queue that is receiving the directives from the agent. So the server sends the directives up into the agents that are subscribing, and now they know what their job in the world is, and they'll continuously start performing that job. So you can see the far left agent there is only doing 1 thing, generating protocol metadata, and then we see there's a variety of different mixing and matching of components in terms of what functions the others are providing. And just to round this out and talk about how we're using the queue in 2 ways, the first I hope I described well, which would be the actual communication of instruction and directive into the agents themselves. And then the second way we're leveraging the queue is to be the egress point for all of our agents that are in the field. So now that they know what they're doing and they're starting to generate data, they're egressing it into a messaging queue, and that is where the MantisNet DMARC is. We do not have a built-in analytics solution. Our goal here is to do 1 thing that we know how to do and to do it well, and that is to gain access to the information in a containerized environment and to egress it into the most open location we can think of, which would be a messaging queue, so that analytics can either pull that down in a streaming fashion if you have a event stream processing engine, or pull it down asynchronously if you're looking at a more batch mode analytics solution. But that is where our DMARC line is, and just wanted to make sure to mention that. So really briefly, we'll take just quick recap on the server and the agent. So the server, once again, managed to deploy those multiple agents, issues the tasks and directives. The one thing I haven't discussed yet is the server is the interaction point of our overall architecture or fabric in terms of being controlled by other analytics and individuals reaching out into our API. They would be reaching into the server. And on the final slide, we'll go through a scenario to show exactly what we're leveraging and how we do that. And then from the design approach and performance impact, because we're leveraging a 100% cloud native design here, the whole goal from both the servers and the agents themselves is to be lightweight containerized pieces of the overall puzzle that are going to aim to ensure minimal resource utilization. However, to take it a step further, we're also including the capability to throttle that or to set a line in the sand to say we do not want this container to exceed X percent of resource utilization. So that capability is included with both the server and the container itself if there is a concern of overutilizing any resource. Then looking at the agents, I think we covered most points here previously. Starting with the most important is you're no longer responsible just for that inter-device or inter-entity, the A to B. You're now needing to see into the intra, the virtual, the insides of those devices, being able to correlate the actual application endpoints and network events, and then looking at the communication sessions that are encrypted. There's no way you could accomplish any of these things without being container-based. And then just to really have a visibility architecture that's going to allow you to deal with a dynamically changing environment being 5G resources. If you think about whether you're at that true standalone 5G cloud native architecture of today or you're on your path towards it, we feel that the best way to achieve a successful visibility strategy is to mirror the actual design approach, and that is to leverage a container-based design and approach to visibility. Once again, I think we hit all the points here on the design approach and performance impact. Elliot, would you like to take a moment here and just discuss your whole concept in terms of how these containers are going to be using resources?
Sure. As a design goal, we've essentially kind of focused on creating a small footprint. Minimum utilization of resources is obviously kind of a primary goal. At the same time, though, the level of sort of detail that we're providing sort of indicates is higher than just a small resource footprint might entail. So what we've done is we've given people the ability to threshold the resources that are actually used. And in some cases, I think people will keep as separate scalable sorts of things so that they can actually do monitoring and visibility, not as a side or a secondary sort of function, but as a primary. People the need to sort of do the work that's required. We have a design goal that's focused on essentially creating the smallest footprint possible, and we're using some really advanced technologies like eBPF to do this. I think that probably addresses most of what you're getting at there, Mike.
Yep. No, thank you, Elliot. That does help. And just finally, I will add from a design approach standpoint is having the ability to leverage the messaging queue for upgrading or updating the agents that are in the field, be it changing the functionality as we've gone over in depth, or moving from a version 1 to a version 2 to be able to do that in a rolling update fashion where we're not requiring a maintenance window of downtime. So where I'd like to take the conversation next is to look at a 5G-centric view of the world and to see how these agent sensors can be utilized in terms of generating protocol metadata that's specific to 5G. So we'll see some sensors pop up on this screen here that are dedicated to focusing on different protocols within a 5G environment, whether you're looking out towards the edge with F1AP or eCPRI or back towards the core with PFCP or even just focusing on the service-based interfaces. All of these agents are out in the field and they'll be generating the protocol metadata that's, the server is essentially requesting them to provide. And as we discussed, we have the messaging queue here that is going to be the egress point, if you will, for all of these servers. Just a quick note about messaging queues. Sometimes it's helpful to point out the obvious is just, it does give you some flexibility in terms of how you're segmenting your data from an analytic resource standpoint, whether you're looking at a singular sensor publishing to a singular topic, such as the F1AP sensor here in this diagram, or if you have multiple sensors looking at the same network protocol, the 2NGAP here, for example, publishing into either separate NGAP metadata topics or a singular one. It's just inherent. There's nothing MantisNet is adding here, but it does just natively within a messaging queue give you that flexibility to segment up your topics if that makes more sense for the analytics stack you have. What I'd like to do also is just focus on exactly what we mean by metadata here at MantisNet. So let's go ahead and look at an example of GTPU metadata. So, metadata is used by a lot of folks in a lot of different ways, and what we're not doing with metadata is we're not taking a very wide brush stroke pass at what we consider metadata to be. The example I have in front of you shows you roughly 40 key value pairs that we're generating for GTPU. So really, to boil it down, imagine MantisNet is that black box in the middle. You have unstructured traffic coming into it, and on the egress side, on the right-hand side, are coming out structured key value pairs that are serialized in JSON or a variety of different serialization techniques to be feeding the analytics stack. And the goal here is really to provide granular information that is structured in such a way that analytics can decide what is best to use, what pieces of information they need to actually be receiving over time, and to also fuel some of the analytics that are being driven by the latest and greatest in data science, being it artificial intelligence, machine learning, whatever the buzzword of the day is. What those emerging analytic approaches are good at dealing with is structured data. What networks, whether they're based on hardware or container technology, what they're not delivering is structured information to those analytics. So our metadata approach is to provide and add that structure to the high level understanding of what's occurring across the network, and to package it up in a format that is most optimal for ingest by those analytics. All right, so finally here I'd like to spend some time on just a review of the overall architecture and just really how the system is used in an artificial but somewhat real way here we have in front of us. So just to set the stage, we obviously have those green agents that are transposed on top of that high-level 5G environment. Then on the bottom left-hand side, we have the gray MantisNet server that's responsible for controlling those agents. On the bottom here, we have the analytics, different types of analytics, whether it's a custom analytic pipeline or workflow, batch mode analytic solutions, true streaming analytic solutions, or even looking at sending this information into an S3 bucket or any other storage target for forensic inspection. And then what's tying everything together in the middle is the messaging queue. And you'll see we have the different egress points, which would be the color-coded, the topology, flow, protocol, et cetera. And then we have our black command and control topic here. So now we'll see some animation move on the screen, and I'll just walk through a narrative of how changes can be made to this environment, and hopefully this simple illustration that just helps better provide just a good view of how this all works. So starting with the gray server down on the left-hand side, that's responsible for sending up the instruction into the agents themselves. So it will issue those tasks. It'll start publishing it into the command and control topic. And as those black directives move up, we'll see now that all of the agents have their job in the world, and they're going to start egressing traffic down into the message queue itself, segmented by the topic that is representative of the functions or function that each agent is doing. So as you can see, all of these agents are acting independently. They all individually receive their instruction about what their job in the world is. We have, up here in the backhaul part of the network, we have, 3 network functions that are being performed, be it packet data topology and flow data. On the right-hand side up here, towards the internet portion of this, we just have a singular function sensor, if you will, sending down that topology data. So now let's take a look at a scenario where we want to make a change to the environment. And by we, let's say it's the custom analytic pipeline down here where a change needs to be made to the MTSO sensor up on top. If you notice, it currently is not egressing any traffic at all. So what the custom analytic pipeline would like to do is it would like to enable that MTSO sensor, turn it on, and to have it start capturing packets. So how this would work is that custom analytic pipeline will reach out via a GraphQL query, And then once it establishes that query into the server API itself, they can send the change request directly into the server as a touch point into the MantisNet Visibility Fabric. And then the server will take the change request, issue a new directive up to the MTSO. The agent will be turned on, and the raw packet data will start coming down into the actual queue itself. So very, very simple example here, but just wanted to point out that this is how the change can be made. It's leveraging GraphQL. We really do think that is the best path forward in terms of interacting with APIs standpoint. And another thing I'd like to point out is as that change was made to the MTSO agent on top, that happened completely independent of all the other agents. So let's also take a look at another scenario where we might want to do something different than just simply turning an agent on and have it start generating data. So we'll go ahead and focus on the local edge network A sensor here. So you'll see it is currently sending it down that purple flow data and the red topology data. And let's say that the new directive we want to issue is to say, I also would like you to start sending XNAP specific protocol metadata. And instead of it coming directly from the analytics down here, we have an individual user in the environment that would like to make the change. So in this scenario, once again, leveraging GraphQL, you'd have an individual user reach into the MantisNet server's API via that query. It'll issue a change request up to the network A sensor, and you will see that it will now begin sending down the purple flow data, the red data, and the new yellow protocol data. So nothing changed in terms of how the other agents are interacting in this environment. Even the local edge network A sensor itself, that topology and flow data didn't pause. There was no downtime for it to now start begin to send down the protocol metadata as well. So this, I hope it serves, I'm a very visual person, so I hope this serves some folks on the line to better understand exactly how the environment works and how it can be changed over time and how to best interact with it. So to move on to a bit of a recap discussion here before we open up the line for Q&A, really looking at the Containerized Visibility Fabric, this is 100% cloud native. It's, it's a containerized network function, CNF. I've been seeing that acronym being used more, but that's the approach we're taking. It's a truly containerized network function, and really what this means, it's unlike some legacy systems, there's no dedicated monitoring fabric. We're not requiring VM infrastructures. So if you think about where this can be used, it's almost anywhere. Really, we can be running on bare metal cloud-native infrastructure or on previous generations of virtualized cloud infrastructure, or even just on Linux appliances for on-prem infrastructure itself. And then, really thinking about the overall containerized network function approach here and how we're leveraging the messaging queue, it's really to have that service-oriented, the pub-sub architecture that's built using a standard messaging bus, and we're utilizing open management interfaces, being it GraphQL and or others. And if there are any potential questions on the line regarding like the metadata, formatting, JSON, protocol buff, Avro, there's a variety of different ways we can egress our information as well. And then, once again, looking at this being a composable disaggregated design, composable meaning we have multiple functions that can be accomplished. We laid out what we have available today. We'll be developing those plugins further in the future and then opening up and then encouraging our partners to develop those plugins as well, and disaggregated, obviously, being able to deploy in a distributed fashion and not require a central tie-in point that will limit you from a horizontal scale point. So we're not requiring our agents that are serving a tap function to then send back to a singular point to perform more of the compute. We're pushing all of our functionality out to the edge, and we're performing it at that individual container level and leveraging the messaging queue to continuously update and manage those environments, or the agents within the environment rather. And scalable complete visibility and GraphQL driven, I think we've discussed that pretty significantly. So with that, I think I will send it back to you, Marshall, for the Q&A portion.
All right, thanks, Mike, for that great presentation on the value of containerized visibility functions. So we didn't touch on all the use cases here, but focused on managing 5G deployments. But you can begin to understand how these functions can help with network performance monitoring and security. Elliot, do you want to expand on those kind of applications briefly?
Sure. We imagine that people will, benefit from actually using our probes, the sensors themselves, to generate raw data. Those data feeds as a, subscriber or consumer of the topic metadata could actually be used for a whole variety of different, post-analytic sort of steps related to application performance monitoring, as well as network performance monitoring. More importantly, though, the plug-in sort of or modular way that we've designed this architecture, it gives us the ability to actually create engines ourselves, right? So this plug-in spec will be something that's open source. It's not proprietary. So if people want to design a plugin that they would like, they can do that as well. But among the plugins that we have in mind to produce commercially are related to network performance monitoring. So we can help with that NPM and APM in a couple of in more than a couple of different ways.
Excellent. And so part of your answer touches on another question that came in about, why did you design the system around the messaging bus? If you can add a little bit about the benefits of designing around a messaging bus.
Absolutely. That's a great question, and I'd love to answer that one. What drove us towards a messaging bus or a distributed messaging queue, however you want to describe it, is essentially the value of, first of all, time to value proposition associated with data. We have an interest in actually acting on data as soon as it's available to us. These types of message queues allow us to build streaming analytic workflows, event-driven architectures. It also supports, as Mike shared in the presentation, the ability to do things in batch mode as well. So there's no problem. You can deal with the data synchronously or asynchronously. But we believe that the future is sort of in time to value, recognizing the time to value proposition of the data that you're capturing, number one, and being able to act on it as soon as you see it.
Very good. If anybody wants to submit another question, we will be concluding the webinar after this next one that I've got, unless another one comes in. But the questions around pricing, can you talk about pricing? And I can add to that, we've got an aggressive volume pricing tier based on the number of sensors that you need. And remember, you don't have to deploy for every endpoint unless you want it that way, but we do have kind of those tiered volume pricing bundles. We also offer a trial program for qualified organizations that provides an entry bundle of sensors to assess the benefits within your environments. And if anybody's interested in those, you want to learn more about those, the volume pricing or the trial program, give us a call, email us, or reach out via our website, and we can discuss from there your unique situation. We did have another question come in. Let's see here. How is the solution presented here? How does it work in LTD or backwards compatibility? And then what is the difference between agent-based and passive probing? It's kind of a two-parter there. Well, I guess two different ones.
Did you want me to take that one, Marshall?
Yeah, Elliot, if you can take that one.
Okay. So in the cases where, what we've described in this presentation is clearly a 5G SA type system, so standalone, and an NSA system, which will be, a variety of people will deploy in non-standalone systems. There will obviously be some ability to reach back. So the N26 interface between the AMF and the MME clearly gives us, opportunity to get at the underlying information. If you're talking about being able to, if you're asking the question, are you able to...
Elliot, you started to break up there. Sorry about that. You started to break up there at the end.
Can you hear me now?
I can hear you now.
Okay. So being able to use our containers sort of in an LTE system to probe all of the other different protocol or interfaces where protocols exist would be a challenge, because it's not a cloud native environment. But if you set up the infrastructure and create your own cloud native interface, then the answer is yes. That would be above and beyond what already exists. So the agents are clearly virtual. We can also set up probes that do the same thing by feeding them physical packets from physical networks. So the answer is we can support both.
All right. Thank you. Let's see here. At this time, we don't have any more questions. If some should come in as we conclude, like I said, we'll answer those with an email. But right now, I want to thank everybody for their time today. Give a few minutes back to you in your day. Mike and Elliot, thanks for your time in the presentation, and everybody have a great day.
All right. Thank you all that took the time to join us. Have a great day.